first question. If the sum and the product of the zeros of the polynomial, this given polynomial, are equal to 10 each, find the value of A and C. Okay, so sum of the zeros is 10 and product of zeros is also 10. So we know the sum of zeros alpha plus beta is same as minus B by A, and alpha beta is C by A. Both of these alpha plus beta and alpha beta both are given as 10. Okay, now in the given polynomial, in place of A we have A itself, in place of B we have minus 5, and in place of C we have C itself. So minus B by A, what will happen to that? Minus B by A will become minus of, in place of B we have minus 5, so minus of minus 5 by A is 10. Okay, we will solve this. See, negative of negative, minus minus together will become positive. So 5 by A is equal to 10, or what we can say, let us take this A to the right side. Okay, so 10A is equal to 5. Here A is in the denominator part, division. When we take it to the other side, it becomes multiplication. That is how we got it as 10A. 10 is equal to 5. That means A is equal to 1 by 2. Now similarly, let us take this C by A. In place of C we have C, and we got the value of A as 1 by 2 here. So what we can deduce from here is C by 1 by 2 is equal to 10. Okay, so in the next step, let us take this 1 by 2 the right side. So division, see C divided by 1 by 2. On the other side, it will be multiplication. So C is equal to 10 into 1 by 2. That is C is equal to 5. This is our second question. Find the value of K such that P of X has sum of its zeros equal to half of their product. Sum of its zeros, that is alpha plus beta, is half of their product, half of alpha beta. This is the given data. Sum of the zeros of the polynomial is half of the product of the zeros. And let us take this given polynomial here. In place of A, we have 1. In place of B, we have minus of K plus 6. And in place of C, we have 2 times 2K minus 1. Okay, so we got A, B, and C. And what is alpha plus beta? Minus B by A. So alpha plus beta is minus B by A. Here B is negative. So minus of minus will become positive, right? So we can write it as K plus 6 by A. In place of A, we have 1. So it is K plus 6 by 1. Now alpha beta is C by A. In place of C, we have 2 into 2K minus 1 by 1. Okay, now let us apply these values in this given equation or in this given data. So alpha plus beta is K plus 6, right? See here, alpha plus beta is K plus 6 and alpha beta is 2 times this. So here this is equal to alpha plus beta is equal to half of. So 1 by 2 into alpha beta 2 times this. So 2 into 2K minus 1. So K plus 6 equal to 2K minus 1. And now in order to get the value of K, let us take this 1K to the right side because on the right side we have 2K. So 2K minus K. And what about the left side? On left side we have a 6. And let us take this negative 1 to the left side. So negative 1 will become positive 1. Now 2K minus K is K. So we got the value of K as 7. 6 plus 1, 7. This is our third question. Form a quadratic polynomial whose zeros are 3 alpha and 3 beta, where alpha beta are the zeros of the polynomial 2x square minus 3x plus 1. So we have to form a quadratic equation, right? And the zeros of that new quadratic equation should be 3 alpha and 3 beta. So the new quadratic equation will be P of x equal to x square minus alpha plus beta. In place of alpha beta, we have 3 alpha plus 3 beta, because 3 alpha and 3 beta are to be the zeros of the new polynomial into x, alpha plus beta into x plus alpha beta. In place of alpha, we have 3 alpha. In place of beta, we have 3 beta. This is the required quadratic polynomial. And what is this? X square minus 3 alpha plus 3 beta. See, from here we can take this 3 outside because 3 is common. So 3 times alpha plus beta into x. And here 3 alpha into 3 beta. That is 3 into 3, 9. 9 alpha beta. So this is the required polynomial. Now, alpha beta are the zeros of this one, right? This polynomial. That is 2x square minus 3x plus 1. Here in place of A, we have 2. In place of B, we have minus 3. And in place of C, we have 1. So alpha beta are the zeros of this polynomial. Means alpha plus beta is minus B by A. See, here in place of B, we have a negative number. So negative into negative. Alpha plus beta will become positive. Minus B by A. So this will become 3 by 2. And alpha beta is C by A. That is 1 by 2. Now let us give these values here. So it is x square minus 3 into alpha plus beta is 3 by 2. So into 3 by 2 into x plus 9 into alpha beta. Alpha beta is 1 by 2. So this is the answer, x square minus, now 3 into 3, 9. 9 by 2x plus 9 by 2. Okay, now we can multiply throughout by 2. That is 2 times 2 times x square minus 9x plus 9. Actually, this is the required polynomial, and let us take it as by 2 over there. That is 1 by 2 into 2x square minus 9x plus 9. This is the required polynomial. Actually, we can write the polynomial as 2x square minus 9x plus 9 itself. This is our next question. Show that 1 by 2 and minus 3 by 2 are the zeros of the polynomial 4x square plus 4x minus 3, and verify the relation between the zeros and coefficients of the polynomial. So here we have to show that these given two values are the zeros. Okay, so two parts are there for the question. First one is we have to prove that those are the zeros, and the second one is verification. Okay, first how to find that there, or how we can show that they are the zeros. Here the given polynomial, let us take it as p of x, that is 4x square plus 4x minus 3. Now, if 1 by 2 is a 0, that means p of 1 by 2 should be 0. So let us take what is the value of p of 1 by 2. For to get the value, we have to substitute 1 by 2 in place of x. Okay, so 4 into 1 by 2 square plus 4 into 1 by 2 minus 3. Let us check what is the value, and is equal to 1 by 2 the whole square. 1 by 2 into 1 by 2, that is 1 by 4. So that it is 4 into 1 by 4 plus 4 into 1 by 2 minus 3. Now, in the next step, we should do multiplication first. 4 into 1 by 4. See, we can cut this 4 and 4. That is, this is 1. Then 4 into 1 by 2. Here we can cut it, and we will get a 2 and then minus 3. So 1 plus 2, that is 3 minus 3 equal to 0. So what we can say, p of 1 by 2 is equal to 0. That means 1 by 2 is a 0 of the polynomial. In the same way, we have to prove that minus 3 by 2 is also a 0 of this polynomial. So we have to find the value of p of minus 3 by 2. For that, in place of x, we have to substitute minus 3 by 2. So it will become 4 into minus 3 by 2 the whole square plus 4 into minus 3 by 2 minus 3. Okay, here 4 into minus 3 by 2 the whole square. Minus 3 by 2 the whole square is minus 3 by 2 into minus 3 by 2. When we multiply two negative numbers, it should be positive multiplication of negatives. So minus 3 into minus 3, 9. 9 by 4, right? So here we can take it that 9 by 4. So it will become 4 into 9 by 4 plus, see, 4 into negative 3 here, right? 4 into negative 3. So negative 12 by 2 minus 3. Okay. Now, here we can cut this 4 and 4. So this number is 9 because we have to do multiplication first and then only we have to do the plus addition or subtraction. So see, negative 12 by 2, that is negative 6 and again minus 3. 9 minus 6 is 3. So 3 minus 3, 0. See, what we got is p of minus 3 by 2 is also 0. So what we can say, since these two values are 0, we can say that 1 by 2 and negative 1 by 2 and negative 3 by 2 are zeros. Zeros of p of x. Now, the question is not completely done. We have to verify the relation between the zeros. So this is the given polynomial. Okay, this is the given polynomial. We know for a quadratic polynomial, there will be only two zeros, maximum two zeros. Okay, so the zeros are these two. So we can take alpha as 1 by 2 and beta as minus 3 by 2. Now, let us compare the coefficients here. In place of a, we have a. In place of b, we have 4. And in place of c, we have negative 3. So what is minus b by a? That is minus of 4 by 4. See, minus of 4 by 4, that is minus 1. And c by a. C by a is negative 3 by 4. Now let us check what happens when we add the zeros, alpha plus beta. Alpha plus beta is 1 by 2 plus minus 3 by 2. When we add two fractions, both are having the same denominator here, so we can just add the numerators 1 plus minus 3 all divided by 2 and 1 plus minus 3. See, the negative number is bigger and this is addition. So the answer is negative 2. So negative 2 by 2, that is negative 1. See, alpha plus beta is negative 1 and here we got minus b by a as negative 1. So we can say alpha plus beta is minus b by a, verified, right? Similarly, let us check the value of alpha beta. Alpha beta is 1 by 2 into 3 by 2. Okay, see here 1 into 3. So it is 3 and 2 into 2 in the denominator it is 4. See here alpha beta is c by a and c. Okay, listen. Actually, in place of alpha, it was 1 by 2 and in place of beta, it was minus 3 by 2, right? So here, alpha beta is 1 by 2 into minus 3 by 2, that is minus 3 by 4. Okay, now it is okay. We see c by a also, we got it as minus 3 by 4 and here alpha beta is also minus 3 by 4. So what we can say, alpha beta is equal to c by a is also verified. This is our fifth question. If alpha, beta, gamma are zeros of this polynomial, then find the value of alpha raised to minus 1, beta raised to minus 1, gamma raised to minus 1. Okay, see here the given polynomial is cubic polynomial. So we know there is maximum 3 zeros and normally we take them as alpha, beta, gamma. Okay, and we know the relation alpha plus beta plus gamma is equal to minus b by a, and alpha beta plus beta gamma plus alpha gamma is c by a, and one more relation is there, that is alpha beta gamma is equal to minus b by a. These are the non-equations. And what we have to find now, see, this is what is asked, alpha raised to minus 1 plus beta raised to minus 1 plus gamma raised to minus 1. So let us check what is that actually. Alpha raised to minus 1 plus beta raised to minus 1 plus gamma raised to minus 1. See, a raised to minus 1 is 1 by a, right? Because a raised to minus n is 1 by a raised to n. We know that is the rules of exponents. So we can take it as 1 by alpha plus 1 by beta plus 1 by gamma. Okay, now let us take multiply, or let us add these fractions. Okay, alpha, beta, gamma, that is the LCM part or the denominator part, alpha, beta, gamma. Now, here what we will have in the numerator part, alpha is already there in the denominator, so beta gamma will be here, beta gamma plus alpha gamma plus beta alpha. See, this is what we have to find, and this is alpha beta plus beta gamma plus alpha gamma, that is c by a, right? See here, it is c by a, and the denominator part what we have is alpha beta gamma. Okay, so we understood that this we can get the answer from the coefficients itself. The given polynomial is p of x 6x cube plus 3x square minus 5x plus 1. Here in place of a we have 6, in place of b we have 3, in place of c we have minus 5, and d is 1. Okay, now we need the value this, right? C by a, that is minus 5 by 6, and minus d by a, that is minus 1 by 6. Okay, now let us take what we need. This is what we have to find out. We need this as the answer. Okay, now alpha beta, beta gamma, and alpha gamma. See, that is minus 5 by 6. So let us take it as minus 5 by 6 by, and alpha beta gamma is minus 1 by 6. So 6 is denominator as in the both parts, right? Numerator and denominator we have by 6. So we can cancel, and negative number by negative number, so it is positive. So the final answer is 5.